This is the first video in a series of videos showing how I'm going to convert my Twinstar 2 to FPV. This was a Twinstar I built originally in 2007, and I've since then done a lamination job on it to give it some more strength and durability. And now, in the coming videos, I'll show the process of where I'm going to place all the components. And the first thing I'll probably do in the next few videos, I'll show how I'm going to make some hatches here on the side, maybe one here and one here to get at the equipment, and maybe another one on the back end here possibly. I haven't really decided yet. But I'll be taking out the old 72 megahertz radio transmitter equipment, the receiver in the plane, converting that to UZUhf for longer range. And here's some of the equipment that's going to go in it in the next few videos. First up is the UZUhf receiver from RMRC. My lovely assistant will show us a closer view of that guy. That will replace the existing one, giving us 1 mile to, some people have gotten 10 or more miles on that guy, depending on the antenna. And we have the Vector GPS on-screen display module. He'll go somewhere in the center of the plane. And we have, in addition, I'll use the airspeed expander to give a true airspeed instead of GPS ground speed with the Vector. That's by Eagle Tree Systems. And it also has a GPS module, and this is how big that is. That'll go towards the tail of the plane most likely. That's the actual GPS module. And then up in the front we're going to have a ready-made RC transmitter, 1.3 and 800 milliwatt, and the Runcam HD camera. They'll sit in a pod that I got from Ready-Made RC. I haven't put together yet, and that's how big they are. That'll be the FPV pod in the front. They'll sit on that. And that's the let's see, what's it called? The Ready-Made RC CXN Mobius actually is the exact model of the one I got that I'm going to put on the front. And that's about it for now. So in the meantime, make some cuts on this, take out the old stuff, and start putting in the new modules, and I'll show how that's going to go in the next few videos. Alright, following up here, I've made the cuts in the plane. I've made 2 hatches here on the right side of the plane, and there you can see how that'll be. I have to hinge the doors on there. I'm going to use Dupro hinges and some welder's glue on the door with some rare earth magnets. That's the plan there. Down in there will sit the Vector, most likely. And back here will be the UZUhf. And then on the other side, I did make one other hatch just in case I need it. It's kind of in the area of the UZUhf as well. And I should have plenty of access ports here to work on this guy as needed. Alright, I've got back here with the video, the second part. I've got everything laid out, ready to do some soldering next and getting the wiring done. Here's the wing section. And we can see from the wing I have a Y coming off the ESCs here and to a Dean's connector here. Now that guy will interface with the Vector current sensor. That is, right there's the current sensor for the Vector. He'll go on the ESC side. I'm going to make a connector here, a Dean's connector, attach a solder that guy onto there. On the other side, the battery will connect in. On that side, here's the main Vector unit, and as we can see, get past the glare here, we have the PPM aileron cable labeled aileron off of these guys that aren't going to be used. That's why they're tied up. I'll probably end up pulling the pins on those guys. because they're not going to be used. They'll just be excess stuff to get in the way inside the plane. You have the one cable sending the PPM signal for all the other channels to the UZUhf receiver in the plane. And then the way we will connect all the servos and the control surfaces will be right there on the left side. I don't have them plugged in obviously here, but below that connector and down to the PPM cable, they'll all go in on the side there. And over here we have the voltage connections that come from the current sensor. The battery feeds the signal, the power down this way. This is 12 volt. We have a 5 volt connector here, which I may or may not be using. I haven't finalized this wiring, so this is a work in progress. As of right now, I have the video transmitter coming in like this. It goes into the video transmitter connector there, and the audio there. So it gets its voltage from these connectors, which are 12 volt. This is a 12 volt transmitter. On the other side of things, we have the Runcam Sky HD. Now, he will not be wired as shown here. I should take this out. Hold on a second. Actually, take that guy out. As of right now, self-powered on the camera. And that goes into the camera connection right there. Self-powered. Now, there is a power connector, but I don't want to put that on this bus because that could cause noise coming from the servo side of things. Try to minimize the noise factor. What I might do, this may or may not work, you guys can chime in the comment sections on anything you see here for that matter, but I might take this red cable here, a power connector, pull it out of the servo connector and put it into that guy right there, the camera connection, to provide power. Now whether on this end of things it'll all work out to feed it power, I'm not sure yet. This guy is 5 volts, and the problem with you can't just take this camera cable and connect it up to the 5 volt lead because they're both male. So that won't work, and there are two different types too. That's a little tiny 2-pin. And the last piece here that I haven't fully decided on yet is this UZUhf battery eliminator circuit, and we can use this UZUhf soldering this little red terminal onto here, and then the other end going into AUX 2 right there to provide power to this side of the vector, because without the 5 volt connection there we have no power. And the UZUhf may or may not be needed. You don't really need a UZUhf. I could use the BECs that are on the ESCs and not use that and just provide power otherwise. But I might do it just to kind of make it a secondary BEC isn't a bad thing to have, I don't think, in this situation. But I would have to disable the red pin of the ESCs coming off the on the servo connections. I'll have to pull the red wires so you don't have something called a ground loop going on. So this is the layout as of right now, and of course I forgot to mention this is the GPS module. He plugs in there, and the other sensor is the airspeed sensor too. And these guys can be daisy chained. There's a bus connector right there, and a bus connector right there too. And the main connection from the sensor right here, I don't know if you can see it, there's a white connector right there, it goes down to there. And that is everything as it stands right now. Next up, I'm going to solder on the two connectors here, Dean's connectors in my case, and probably try to power things up and see if I can at least get the video working. And I'm going to have to program the vector, update the firmware, and I'm going to have to update the firmware on the UZUhf. So that's all coming up. So I decided to go ahead and use the UZUhf, and to do so I put this connector on here, interfaced on the ESC side. You guys can feel free to critique my soldering job, but it's pretty tight. If I wiggle the wires, they're not breaking off. Contact looks good. Not the greatest solder in the world, but I think I got the job done here. Can I see here? And that's that. I'll put the case back on, the cover back on. It was held on by some glue. Just used an X-Acto knife to get it off. To put that back on and be ready to move along here. Okay, alright, now I have attached the UZUhf, as you saw in the previous clip, into the current sensor, and then the UZUhf will go on the left side. One of the auxiliary ports, any of these actually on the left hand side, can provide power. I'm using AUX 2 here to get that 5 volts to power the UZUhf. The PPM cable is right there as before. One change here, the camera cable I had before, a 12 volt connection going on. That wouldn't be good because the camera is 5 volts, and as of right now I have the 5 volt, that's the white connector, going into there, and the goal here is, in the next step, I'm going to take this cable like I mentioned before and pull the red lead out, put it into that one going into the camera port, and that should in theory give 5 volts. Okay, here we have everything laid out again, this time working, at least partially here. I've got the, let's take a look at the vector arrangement now. I have taken this red power pin out of the one connector for the camera and wired it into the vector's camera center pin right there. So now the camera gets power, we have a green light there, and in theory that should only give it power when the battery is low on the internal camera battery, leaving the internal going. And let's see here. So just to demonstrate again, power comes from the battery through the current sensor and then down through these leads here and into your 5 volt being the white, and the red connectors are the 12 volt. In the case of the camera, we went with 5 volt because this camera is 5 volt, although as you'll see in later videos here, I'm probably going to switch to the Sony 800 TVL camera, CCD camera, as the main recording, or not recording, but as the main capture, live capture camera, and use the Runcam HD for just the HD recording. We have the 800 milliwatt transmitter here going, and then on the screen you can see the readout. This is the LCD that will go in the ground station. I have yet to build that. That'll be in a later video as well when I get that completed. I have the eagle eyes set up and connected to the receiver on the receiving end, and then there's a ready-made RC DVR set to record 640 by 480, or I think it might be 576 is the setting I have it on, but it ends up being 640 by 480, and that's for the flight recording on the ground. Alright, this is going to be the first video in a series of videos showing conversion. Come on. Hello everyone, this is the first video in a series of videos for this one.
Bye guys!